questions given in that section. And
Okay.
yes, come over here with this. I have made some. I have email you the this document to you anyway. Right. Okay. So over here, if you come up with this question, so we are discussing about the areas of the curve. So let's go to the question initially. Just let's read out this question, a little bit of it. They mentioned the diagram below, sketch the part of a curve with C with the equation of this bit, x cubed minus 10x squared plus kx, where k is a constant. So the point P is a maximum of the turning point, given that x coordinate of P is 2. So show that k equals to 28. So you know that at a maximum or minimum or point of inflection, we know there's a common theory over here. That is the dy by dx becomes 0. That's a main fact where we have to understand in this kind of a question. So basically, if you come up with this equation, x cubed minus 10x squared plus kx. So if I just start with this. So initially, if you start with this question, part A, the equation is y equals to x cubed minus 10x squared plus kx, right? Over here, initially they mentioned the point P has a maximum for turning point. Anyway, the basic concept of a maximum. So wherever it doesn't matter, it's difference of maximum or minimum or whatever, like point of inflection, or you may say stationary point. All of these facts is a common theory. Dy by dx becomes 0 at that point. So if you find dy by dx, dy by dx is equals to 3x squared minus 20x plus k. So they mentioned that it's a turning point at P. And we know that the x coordinate of P is 2. So therefore you can say dy by dx at x equals to 2. That is equals to 0. So simply you can put 2 squared minus 20 times of 2 plus k is equals to 0. So this is 12 minus 40 plus k is equals to 0. Therefore, k become just obviously 28. Now you know that this equation for next set of questions. Now we know that this equation become y equals to x cubed minus 10x squared plus 28x. We know this fact. Right, okay. Now, the line P is parallel to y-axis, cut the point at N. The region R is bounded by C with the y-axis and PN shown in the diagram. Use the shaded region, right, okay. This is a point where we can understand. So, if you just come up with the question number B, right, sorry, I just use the same color. Yeah. In part B, refer to the question number part B, just a graph is just like this. It travels to origin. It just goes like this. Then we know that it's a straight line. And we know here, we already knew that x coordinate is 2. Right. They are referring to the area over here. This is the area they are referring to. Right. Now you know that over here, this x coordinate is 2 means if you substitute this 2 into the original function, what do you get the y coordinate? 2 cube minus 10 times of 2 squared plus 28 times of 2, right? If you work out over here, you get the answer 2 cube is 8 minus 2 into this is 40 plus 56. So this answer becomes 24. So the y coordinate is 24. So simply what you can understand is here the y coordinate is 24. That means here the coordinate become 2, 24. Right? Then if I need to find the area over here, now you can understand that this is a rectangle. Right? Initially, I'll just get this rectangular area. For this rectangular area, we know that this length is 2 and this height is 24. So this area become how much? 2 into 24, that is 48. Right. Then if you need to find this area, what I need to do is I need to remove this area out of this rectangular part. If I remove this area out of this rectangle, you will get the required area. Now you can understand that here the x-coordinate is 0. Sorry, if you need to find this area, just this bit of it. So if you just count this part of the area, like this kind of it.
Yeah.
Here this is x-coordinate is 0 and here the x-coordinate is 2. And the curve is y equals to 2 cube. Sorry, x cube minus 10x squared plus 28x. So if you need to find this area, what you can do here is you can integrate the graph from 0 to 2, this bit of minus 10x squared plus 28x. So if you do this integration, that is x to the power 4 over 4 minus 10x cube over 3 plus 28x squared over 2 from 0 to 2. So you have to substitute and get this answer. So if you do this integration, you will receive the answer just like this. Right. So you receive the answer as 100 over 3. Right. Then if you need to find the area over here, the shaded region, so what you can do, you can subtract this area under the curve from this rectangle. So you can say region R, area of the region R is 48 minus 100 over 3. So you can understand, you can obtain the answer over here. So you receive the answer 44 over 3. Answer for that. That's the way of doing this question, right? Okay. Right. Okay. Shall we do this question? Just make it a little bit. That is the question and R. Anyway, but you will receive this question. It's there in the your email, so you can refer with that and do it.
Okay.
Okay.
I'll just copy it down, sir.
Yeah, you will copy down. Just that's it. So this is question number 1.
Okay.
So now you can see much clearly. I think now it's fine, right? Then if you come up with the next question of it, just right. Okay, over here, now they have given us this equation, right? Here they have given this equation y equals to x squared minus 5x plus 4. It cut the x-axis at point L and M, right? So initially, how to find this point L and M? These are the two questions you have to understand. Here we know that at L and M, the curve meet the x-axis. So you can say this is a point. So this is the way of understanding this question. So initially at L and M, the curve meets x-axis. So if any curve meets any curve or straight line or whatever it meets x-axis means, basic concept we know is y is equals to 0. Therefore, you can make x squared minus 5x plus 4 is equals to 0. From here, you get the answer x equals to 4 and x equals to 1. So if you just equate to this one, you get this answer. So here here the coordinate is 1, 0, and here the coordinate is 4, 0. 4, 0, right? Okay. Then they mention show that point N56 lie on curve C. If you need to show any curve, any line lie on this one, either you can substitute this x coordinate 5 into this one and show that y become 4, or you can put 4 into y and you can show that x become 4. So the easier concept is to substitute 4 into x and show that y become 5. So I will just do it like this way. 4, this is 5 squared minus 5 into 5 plus 4. Therefore, y equals to 4. So with that, you can say, therefore, n 5, 4 is on curve. That's a way of writing this answer. Then obviously, we know that this point here, if you just this point over here, this coordinate becomes 5 with it. This coordinate is 4 and this coordinate is 1. Those are the facts because we may need this fact to understand this question, right? Okay. Find the integration of this bit of it, right? Okay. Then if you do this integration, it's pretty simple. Answer C, right? So if you integrate x to the power 2 minus 5x plus 4, answer is x cubed over 3 minus 5x squared over 2 plus 4x plus c is the answer for that. Then they mention finite region R is bounded by the line LM, MN and the curve in this as shown in the diagram. Use the answer part C to find the exact value of the area R. So now what you can understand over here is so the this required area, just like here, initially we can find the area of this triangle. Initially, I can find the area of this triangle. It's pretty simple. Here the x coordinate is 1. Here the x coordinate is 5. And that means this length is 4. This length is 4. And we already, obviously, we know that this height. We know that here the coordinate is 5, 4 means y coordinate is 4, it's 4. So simply we can find the area over here. L, this area. I'm just talking about this area. That is equals to half into 4 into 4. I'll just come over here. Initially, part D, area of triangle. So that is half into 4 into 4. 16, it's 8. No need of writing because we don't know the centimeter or anything. You just write it as 8. That means, Pute, we already found this area. Just if I just use a different color to represent it. For the moment, I just found this area. This whole area, I just found it for the moment. Okay. Now, to obtain the required area over here, you can understand that I need to remove this area out of this shape, this bit of it. If I remove this bit of this area, this part of it, this entire stuff over here, you can get this required area. Then this the area under the curve. Actually, it's a shape somewhere like this. It's a curve over here. Here the x coordinate is 4 and here the x coordinate is 5. That's what I'm just talking about. This area we need to remove, right? That is this bit of it. Obviously, this part of it I'm talking about. Now you can understand that this is the area between the curve and the x-axis. So what you need to do is simply you can integrate this x squared minus 5x plus 4. This area is equals to integration of x squared minus 5x plus 4 from 4 to 5. With that, you can obtain the answer over here. So this answer is x cubed over 3 minus 5 over 2 x squared. We already found this one plus 4x, no need of writing c because it's a finite integration from 4 to 5. So we'll be receiving this answer by substituting the upper boundary minus substituting the lower boundary. We already learned how to do this question. That is why I'm just trying to do it. So I just use the calculator and get it. But anyway, you have to do the substitution step and get the answer. That answer become 11 over 6. So this is 11 over 6. Therefore, we need to find the required region. R is, if you subtract this area over here by this one, you get the required region over here. So that is 37 over 6. So this area become 37 over 6. Yeah, that's it. Yeah, okay, that's how to do it with it.
Okay, so I'll just copy.
Yes, sir. If you come up with this question, right? The question number 3, the diagram below is a part of a curve with the equation y equals to 1 plus x and 4 minus x. The curve intersects the x-axis at -1 and 4. It's given, it's over here and here. It's already given over here. This is a pretty simple question. The region R shown in this shaded region diagram, use the calculus to find the exact area over here. So this is a pretty simple question. It's a question is very straightforward. What you need to do is we have to obtain this answer, we can integrate this curve from -1 to 4, this bit of it. 1 plus x, 4 minus x. So straightforward, you cannot do this integration with our basic integration knowledge. So anyway, we have to expand this bracket. So if you expand this bracket, you will receive 4 minus x. So 1 into 4 is 4. 1 into minus x is minus x. X into 4 is 4x. X into minus x is minus x squared. So the final simplification is 4. You can just simplify this, it's plus 3x minus x squared. So with that, you can get this integration is -1 to 4 minus x squared plus 3x plus 4. So it's very easily, you can get this answer minus x cubed over 3 plus 3x squared over 2, 3x squared over 2 plus 4x. You have to integrate from -1 to 4. So with that, you know that to get these answers, initially substitute 4 into this and minus substitute the -1 into this. We already learned in the previous topic. I'll just do the substitution step and show you. To 4 squared plus 4 into 4, substitute the upper boundary minus substitute the lower boundary with it. Minus, we have, you have to put a minus in the brackets over 3 plus 3 times of -1 squared over 2 plus 4 times of -1. So with that, you can obtain this answer very easily. If you integrate it from its 4 to -1, the function is yes. So you receive the answer 125 over 6 per day. So the final answer become 125 over 6 units. So that's a way of getting this answer.
Yeah.
So this should be the final answer for that. Okay, right. Then if you come up with this question, this is a question we are discussing about, right? Okay. Then we come up with this question today. Here, the diagram below shows a sketch of a part of a curve with the equation y equals to 10 plus 8x plus x squared minus x squared. That is this curve today. The curve has a maximum at the point A. Using the calculus, show that x coordinate of A is 2 today. So simply we know that when you're talking about a maximum or a minimum, So the simple condition is dy by dx. So as I discussed before, initially we know that at a maximum or minimum, whatever the condition, if the general concept is dy by dx is equal to 0. From that fact, we can identify some kind of information for this. So initially we can find dy by dx. dy by dx is equals to 10 differentiation is 0, 8x is 8, plus x squared differentiation is 2x minus this is 3x squared. Then you can say at turning point, you can say dy by dx is equals to 0. That means minus 3x squared plus 2x plus 8 is equals to 0. So with that, if you just do the factorizing for this, or you can just, if you simplify this, you can obtain the answer as the factors become, so you can just do the factors. So this is turn up to, so if you simplify this factor, so you can say x is equals to 2 is a one answer, and the other one answer is x is equals to minus 4/3. So with this information, we can obtain the answer as x. So you can say here the point A, it's only 3-mark question. So therefore, no need of doing further improvement of showing that it's a maximum. So anyway, you can say point A is equals to 2. The coordinate of A is 2. So if you need to find x coordinate is 2. So you can say at A, the x coordinate is 2. At A, x is equals to how much? 2. Right. Anyway, now what is the information where we can get it? As soon we get this information, I can just mark this fact on the diagram. Because anyway, when you get concerned about the integration, these coordinates are really important. So this is 2 and this is 0. If you need to find the y coordinate, how do you find the y coordinate? X coordinate is 2, clearly we know this answer. So if you need to find the y coordinate, you can just substitute 2 into this function. Later on, you'll understand that why I'm just finding this y coordinate plus 2 squared minus 2 cubed, right? If you just do this y coordinate, that is 10, 8 into 2 is 16, plus 2 squared is 4, minus 2 cubed is 8. So the y coordinate becomes 22. It's 22. So that is 222. That means simply we know that this length become 2, and this height is equal to 22. But practically we can say that practically these are the facts, but it's not into the scale diagram. Therefore, you just obviously see with the both facts the same lengths, right? Okay. Then they ask about the region R is shown in the shaded diagram bounded by the x-axis, and all these facts are given. Use the calculus to find the exact area R. So simply what you can understand is, initially if I integrate this graph from 0 to 2, integrate the graph from 0 to 2, you will obtain this answer. There is no doubt about that. You can obtain this whole answer. Let's try to do this. You can get this whole answer if you integrate the curve from 0 to 2. So initially, I just find this answer, part B, just like this kind of it. It's this area. You can find area A. A is equals to the integration from, here the x coordinate is 0 and here the x coordinate is 2. So with that, the graph is this bit. Can write that is 10 plus 8x plus x squared minus x cubed. And it's a different color, then it will be much clearer. You can see this. Yeah. So if you do this integration, you can understand that this is from, you have to do it from 0 to 2. 0 to 2. So if you do this integration, that is 10x plus 8x squared divided by 2 plus x cubed over 3 minus x to the power 4 over 4 from 0 to 2. So simply you can get this answer, area A, substitute the upper bound. Upper bound is 2. That is 10 times of 2 plus A divided by 2 is 4 times of 2 squared plus 2 cubed over 3 minus 2 to the power 4 over 4. So minus the lower bound. Anyway, it's a 0. If you substitute 0, obviously it is turned out to 0. So there is no restriction with that. So if you do this integration, you will obtain the answer from 2 to 0. With that, you obtain the answer 104/3. Then if you need to find this required region over here, out of this total area, if you need to find the region R, we have to remove this area. That's the logic. We have to remove this area, this bit of it. This whole area has to be removed, this bit of it. This entire stuff has to be removed, this part. So if you just do this, you can understand that. So you can say that area, it's a triangle. It's a triangle. It's a triangle of base of 2 and height of 22. This area become half into 2 into 22. So it's turned up to 22. Therefore, the required region R you can find by subtracting this area under the curve, subtracting the area of the triangle. So what you need to do is initially from this yellow color area, this whole thing just from here itself, from this entire area, if you subtract this area of this triangle, you can obtain the required region R, right? So you can get this answer. Is this bit with sorry? Right. So minus 22. So you obtain the answer 38/3. So the region R become 38/3. Okay, that's how you need to get this. Okay, just anyway, I think you will have to do it in yeah, this is the initial part of it. After that, we'll come up to the next part of the answer. So initially get this, after that we'll discuss the other part of it. This is the first part of the answer and this other part, right? Okay. So after finishing the first part, I'll come to the next. Right. Then if you turn to the next question, Pate. So here. Right. If you come up with this question, but the question says, in this diagram, the curve has an equation y equals to 6x minus x squared. That's a graph, but it's a curve. And the line y equals to x. So clearly, we need to understand these two equations. That's a straight line. This is y equals to 2x, and this is a curve that is y equals to 6x minus x squared. Initially, show that the curve C intersects the x-axis at 0 and 6. Over here, we need to show that these two meets at x6 and 0. So you know that it meets the x-axis means we know that y coordinate is equals to 0. So simply you can say 6x minus x squared is equals to 0. With that, if you take x out, 6 minus x equals to 0. So with that, x equals to 0 and x equals to 6. So simply we can say this coordinate is 0 and here the coordinate is 6. Right. Then what you need to do is show that the line L intersect the curve at 0.00 and 48. To find the intersection between a curve and a straight line, or between two curves or two straight lines, you have to solve them as simultaneous equations. So we can get the answer for part B by solving these two equations as simultaneous equations. So you can say y equals to 6x minus x squared is my first equation, and other one is y equals to 2x. So with that, you can say both of them are y's, therefore you can equate 1 into 2. 1 is equals to 2. So you can say 6x minus x squared is equals to 2x. If you brought the 2x to other side, 6x minus x squared minus 2x is equals to 0. With that, 6x, sorry, it's turn up to 4x minus x squared is equals to 0. With that, you get the answer x equals to 0 and x equals to 4. Right. So this is important points, right? Okay. Then we know that here the x coordinate is 0. So with that, you can find the y coordinates as well. So you can say y equals to 2x when x equals to 0. Y becomes 0. When x equals to 4, y become 8. Then these are the important points we can understand that with it. Then we know that here the coordinate is, this is important point, that is 4, 8. Right. Then I just mark this x coordinate over here. This is 4. That means this length become how much? 4. And this length is 8. This length is 8. Right. Then the next part, definite question is to find the region R. Right. Initially, if I integrate the curve from 0 to 6, you'll be getting this whole area, this whole thing. But that is not required to find the shaded region R. Shaded region R enclosed in between 0 to 4 only. This part only we need to find the area over here. Then if you integrate this graph from 0 to 4, what kind of area you will receive with it? Area between the curve and the x-axis. That means you can clearly see it encloses this whole area. That is the first area we need to find, right? Okay, this area we can find by integrating the curve from 0 to 4, right? Okay. Let's go ahead with that part and initially come up with the question, right? Then this thing, just like this, it was a graph somewhere like this. We find this area. That one you can get integration from 0 to 4. The curve is 6x minus x squared. 6x minus x squared. So if you do this integration, it's turn up to 6x squared over 2 minus x cube over 3 from 0 to 4. So you can substitute the upper boundary. 6 over 2 is 3. 4 squared minus 4 cube over 3. All the minus, if you substitute 0, is 0. So you can get this answer. That become 80 over 3. Right. Then if you need to find this required region, which area has to be removed? We need to remove, to get the region R, we need to remove this triangular area. This triangle must be removed out of this orange color area to obtain the required region R. I think it's clear with you, so just this bit of it. But to remove this area out of this one, that is a right triangle. This triangle is this bit, 8 and 4. It's a triangle, and actually just like this, obviously. It's 4 and this is 8. This triangle become half into 4 into 8. That is turn up to 16. So with that, you can find the required region R by subtracting the area of the triangle out of this area under curve. That is 80 over 3 minus 16. And this bit. So you can say out of this one, I'm going to remove this area out of that. There you get the required region R. That's a simple idea. So to obtain the answer is 80 over 3 minus 16. So you can obviously get 32 over 3 as a final answer. That's a final answer for that. So if you go ahead with that, you can say it's the first part of the answer. And yeah, let's go to this part of the answer and then go to the next part of it. Yeah. So this initial section, with that you can get the final answer, right? Okay. Let's do this with it. Right. Then when you come up with this question, here the diagram, yeah, so just 1 second. So this is the question we are doing in the first part of it. Then, yeah, that was a second part of the answer. Then, yeah, if you come up with this question, right? Okay. So what you can understand is the above show the sketch of part of the curve with curve C with equation x, x minus 1, x minus 5. Use the calculator to find the total area of the region shown in the shaded with the diagram. Show that in between 0, 2, and plus 2 and yeah, up to 2. Right? That's it. Right. So in this situation, you can say this part of the if you just go ahead with these areas over here, so you can say if I consider this area, this is above x-axis. So obviously if you do this integration, you will get a positive answer for that. But there is another problem over here. If you do this integration for this region, you get a negative answer for that. When you are doing this integration of the previous sessions, we knew that this area you get a negative answer for this. You get a negative answer for this. So therefore, you cannot integrate the you cannot to find the area over here. You cannot integrate from 0 to 2 straightforward. What you need to do here is initially we need to do this integration from 0 to 1 separately and 1 to 2 separately. Let's try to do this integration for these regions separately and try to understand what happened with that. To do this integration initially, we have to expand this bracket because straightforward you cannot do this integration for a product of this kind of 3 different functions. Just like this, if you do this x, if you expand this, there is x squared minus 6x plus 5. So it's turned up to y equals to x cubed minus 6x squared plus 5x, right? Okay. Then I'll do this integration from initially from 0 to 1. Why I'm doing for 0 to 1? Because you know that this is the first area I'm just considering about, right? So if you do this integration, that is x to the power 3 minus 6x squared plus 5x dx. If you do this, its answer is x to the power 4 over 4 minus 6x to the power 3 over 3 plus 5x squared over 2 from 0 to 1, right? Okay. If you do this, you will understand this answer become 1 to the power 4 over 4 minus 6 over 3 is anyway 2, 1 cube plus 5 over 2, 1 squared minus anyway this answer is 0 because when you do this substitute 0 into this function, it becomes 0. So you'll obtain the answer as a 3 over 4, right? 3 over 4, right? Then I'll do the same integration for the next range. Let's see what happened if you get the next range. Next range is from 1 to 2, sorry. It's 1 to 2, right? Okay. If you do this integration from 1 to 2, x cubed minus 6x squared plus 5x, you'll obtain the answer same thing. Only thing is the boundaries are changed. 4 minus 2 x cubed plus 5 over 2 x squared from 1 to 2, right? So if you do this integration, what you get here is 2 to the power 4 over 4 minus 2 times of 2 cubed plus 5 over 2, 2 squared minus substitution of 1 to the 1 to the power 4 over 4 minus 2 times of 1 cube plus 5 over 2 times of 1 squared. So with that you will obtain the answer minus 11 over 4. Why do we get this minus 11 answer? Because you know that anyway this area is underneath of the x-axis. So area encross, just like if you do this first part of it, it's a graph somewhere like this, it's above x-axis. Therefore, you get a positive answer for that. The other part of the answer is just like this. it's underneath of the x-axis. So obviously this answer you get a negative answer for it. So if you want to find the total area over here, we have to ignore this negative part and we have to add them together. So therefore we can find the total region 3/4 plus 11/4, ignoring the negative mark of it. The negative mark indicates you that area is underneath of the x-axis. So it's 14/4 is 7/2 would be the final answer for this. That's a way of doing this question. Then yeah. So you can obtain the answer like this to do this question. Then this next question is a little bit of interesting question. So just if you read at the first part of the question is the figure above show the sketch of a part of a curve with the equation y equals to x cube minus 8x squared plus 20x. Use the calculator to find the coordinate of A and B. Right. So you can say A and B are stationary points, right? Okay. Then what you can understand here is that if it is a stationary point, what the concept we know is if it is a stationary point, point of inflection, maximum, minimum, all of these facts are related with dy by dx equals to 0. So that is a basic thing we need to find it. Dy by dx, if you do it, that is turn up to 3x squared minus 8 into 2 is 16x plus 20. So you can say at A and B, dy by dx becomes 0. That means 3x squared minus 16x plus 20 is equals to 0. So with that, you can get this answer. But you have to solve this quadratic equation, obtain it. I will just get the answers. But anyway, you have to do it by using the formula or just using the factorizing or whatever the method. So that is 10/3 is the one answer. Other answer is 2, right? So this is just roughly, this is 3.33. So obviously we know that according to the diagram here, this value should be 2. So I just mark over here. This is 2 and this is equals to 3.33, or you just write, you can write 10/3 because you have to get the exact answer by just substituting that. That is 10/3. I just get that's 10/3. 10/3, right? Okay. Then coordinate of B, right? So here they are referring to the coordinate, x coordinate only. So we need the x coordinate only here, right? Okay. Find the value for d squared y by dx squared at A and hence verify that A is a maximum. So this is pretty simple. So you just go to the second differentiation part B, d squared y by dx squared. That is the differentiation of this answer. That is 6x minus 16. Then we know that at A, the x coordinate is 2. So if we just work out the x squared at x equals to 2, that is 6 into 2 minus 16 is minus 4. This is less than 0. Therefore, it's a negative answer, means it's a maximum. So that's a verification of doing this question, right? Okay. Then they mention this part of it. Look at this. The line passing through A, B is parallel to x-axis and meet the x-axis at point N. Okay, over here they definitely x coordinate is 10/3. The region R is shaded in figure above is bounded by the curve with the x-axis and this region shown over here. So initially they need to find the integration of this. That is not that hard. So you can just do the integration. See, integration of x cube minus 8x squared plus 20x. If you do this, that is turn up to x to the power 4/4 minus 8x cube over 3 plus 20x squared over 2 plus c. So you can write 1/4 x to the power 4 minus 8/3 x to the power 3 plus 10x squared plus c is the final answer for that, right? Hence, calculate the exact region R. Then how do you find this region R? So you can see what kind of a technique I can use to find the region R. Right? I just little bit expand this. then I just mentioned over here, then you can understand that this area is an enclosure of a curve from 0 to 2. If I just integrate the curve from 0 to 2, this is a way of understanding this question. You can obtain this area very easily. This part of area you can get by, how do you get it with it? By integrating the curve from 0 to 2. X cube minus 8x squared plus 20x. By just doing this, you can get this area. Then this is a triangle. This triangle, how do you find this area of this triangle? Just like this, I just make a triangle over here. Obviously, we know that this length is 2 and this length is 10 over 3. Then you can find this area over here. That is 4 over 3. This side is 4 over 3. Now, if you need this side, if I know this height, obviously we can find the area of this triangle. How do you find the area of this triangle? This height? We know that here, this is the y coordinate of x equals to 2 would be the height over here. So simply, you can find that value. Y equals to, this is 2 cube minus 8 times of 2 squared plus 20 into 2. So that is 2 cube is 8. 8 minus 32 plus 40. So that is turned up to 16. 16. So obviously this height become 16, right? Okay. So we already found that area over here. Then if you need to find the exact area over here, so you can say it's a part D. Part D. It's just a shape somewhere over here, plus it's a triangle. We already found this area. So that is what you need to do is this part you can find anyway. I think we haven't done this integration. So anyway, you get it, right? Okay. So here the x coordinate is 0 to 2. 0 to 2, right? Okay, I think I'm correct. Yeah, it's 0 to 2. Yeah, 0 to 2. So you can do this integration. So that is this bit. This area you can get by integration from 0 to 2. X cube minus 8x squared plus 20x. So this one you can say the same thing we already found from here. It's 1 over 4 x to the power 4 minus 8 over 3 x to the power 3 plus 10x squared from 0 to 2, right? Okay. So obviously we can get this answer. It's 1 over 4 times of 2 to the power 4 minus 8 over 3 times of 2 to the power 3 plus 10 times of 2 to the power 2 minus 0. So with that, you can get this answer. So anyway, the 0 substitution 0. So with that, you can get that is turned up into 68 over 3. So this is 68 over 3 and already found this area, that is half base is 4 over 3 into perpendicular height. We already found from this answer. I think we already found the area over here. That height is 16. The height is 16. The height is 16. So you can get this answer 64 over 6. 32 over 3. So this area become 32 over 3. So with that, you can find the total area. Total area is 68 over 3 plus 32 over 3. So with that, you can get this answer. It is 100 over 3 is the final answer for this. That's a way of doing it.
Sir.
Right, okay. Right, okay. Let's go to the next question.
Okay.
Just like this is a pretty simple question, but here the integration is a little bit of like different, not different actually, you have to do a little bit of working over here. So the figure shows about the part of the curve C with the equation of this. The point A lies on a stationary point C, cut the x-axis at point B. Find x coordinate of point, show that x coordinate of B is 3. It's a 1 mark question, right? There are two approaches for this question. It's just like this. You know that there are two ways you can do this question. I just to show you the long method and the short method itself. So what you can get here is they have given the x coordinate as 3. So you can say at B curve meets x-axis. X-axis. So curve meets x-axis means y equals to 0. So you can say 3 x to the power 1 over 2 minus x to the power, so I just a little bit of expand to get the exact answer. This is 3 over 2, Kute. X to the power 3 over 2 is equals to 0, right? How to do this question, Kute? So here, I can take x to the power half as a common term. This one you can write x to the power half times of x to the power 1. So if you add these two powers, it's turned up to 3 over 2. So if you take it, it's turned up to 3 minus x is equals to 0. With that, you can say x is equals to 0 and x equals to 3. So simply that is the first way of doing this question. The second method is just like this. Yeah, the second method is, you know that it's already x coordinate is given. So if you just substitute 3 to the function, so you can say 3 times of 3 to the power half minus 3 to the power 3 over 2. So the answer y equals to 3 root 3 minus 3 root 3, that is equals to 0. So obviously 3, 0. So we can say the point C is the same thing, right? Okay. So anyway, the important facts we have to understand here is, here the x coordinate is 3 and here the x coordinate is 0. That is important with us. Find the coordinate of A. You can say that A is a stationary point. That is a point it's kind of important for this question. Is B at A dy by dx is equals to 0. So initially you can find dy by dx. So if you do this integrate, if you differentiate this function, this is 3 into half, x to the power half minus 1 is minus half, minus 3 over 2, x to the power 3 over 2 minus 1 is 1 over 2. Okay. With that, you can say this is 3 over 2. I can draw this half to square denominator, make this plus half, minus 3 over 2 x to the power half. This is equals to 0 at the turning point. With that, you can say this is 3 over 2 x to the power half minus 3 over 2 x to the power half is equals to 0. To solve this fact, initially multiply everything with x to the power half, all the terms. So this is turned up to 3 over 2 minus 3 over 2 x to the power half plus 1 is 1 is equals to 0. So with that, you can say 3 over 2 is equals to 3 over 2x. That means you can say x become 1. So x coordinate over here is 1. So yeah, they ask about the coordinate of A. So if you need to find the coordinate of A, what you need to do is, x coordinate we know, x coordinate is 1. We need to find the y coordinate. How to find the y coordinate? Substitute 1 into the curve. 3 times of 1 to the power half minus 1 to the power 3 over 2. 1 to the power 3 over 2. So with that, you get the answer 2. So this coordinate is 1, 2. Right. Initially, we can just get this answer. This is 1, 2 is a coordinate over here. You might need this fact. That's why I just try marking the diagram. Then find the area. So that is pretty simple. If you need to find the area, C, yeah, that's you can understand that if you need to find the area, you have to integrate the curve from 0 to 3. 0 to 3, this function you can integrate. So you can integrate from 0 to 3. 3x to the power half minus x to the power 3 over 2. If you integrate this, it is turned up to 3x to the power half plus 1 is 3 over 2 over 3 over 2. Minus x to the power 3 over 2 plus 1 is 5 over 2 over 5 over 2 from 0 to 3. Okay, if you do this, it's turn up to 2 goes up and 3 get cancels. 2x to the power 3 over 2. If you simplify this, 3 divided by 3 over 2 is 2. Minus 1 divided by 5 over 2 is 2 over 5. X to the power 5 over 2 from 0 to 3. Right. Then you can do this integration. So you can substitute 3. 2, 3 to the power 3 over 2 minus 2 over 5, 3 to the power 5 over 2. Minus 0 substitution is 0 with it. Now, how do you find this 3 to the power 3 over 2? So you can say this is the point you can understand. Right. Okay. This is a little bit of like contradictory for certain students, right? We'll see how to do this. You can understand that here this is 3 to the power 3 over 2. You can write 3 to the power half to the power 3. Okay. So you see, if you multiply, you get the same answer. That means root 3 to the power 3. That is root 3 into root 3 into root 3. That is 3 root 3. Right. That is, you can say 2 times of 3 root 3. Right. Minus 5 over 2 times of 3 to the power 5 over 2. The same technique I am using. 3 to the power 5 over 2, you can say 3 to the power half to the power 5. That is root 3 into root 3 into root 3 into root 3 into root 3. So this is 3. This is also 3 into root 3. That is 9 root 3. It's 9 root 3, right, into. So this is turned up to 6 root. Sorry, this is not root 2, it should be 3. Just made a mistake. 6 root 3 minus 45 over 2 root 3. So with that, you get the answer. Have you made any mistake?
Okay.
Yeah. So yeah, this is 6. Just what is the problem over here? 3 into 3 over 2 to power 3 over 2 is 6 over. It's 2 this much. It's 2 over 5. It's 2 over 5. Sorry, this is I made a mistake over here, but this is not 5 over 2. It should be how much? It should be this is the point I made a mistake. This is not 5 over 2. It should be 2 over 5. This should be just 2 over 5. 2 over 5. So it's turned up to 18 over 5. So 30. 30 minus 18 is 12. Root 3 over 5 would be the final answer for this. That's the answer for that. That's the way of doing this kind of a question. So we'll go to the first part of the question and then come to the next part. Yeah, this is a question. Yeah. Yes, then when you come across the question over here, yes, the figure above shows the shaded region R is bounded by the line y equals to minus 2x plus y. It's a straight line today. So therefore, clearly we need to understand this is the straight line which is enclosing by y equals to minus 2x plus 4. And the curve 3 over 2x. So this is the curve part is the one. It's y equals to 3 over 2x. It is part of it. So anyway, initially we need to find the coordinates of A and B today. To find the coordinates of A and B, we have to solve them as simultaneous equations. So you can say y equals to minus 2x plus 4 is my first equation. Y equals to 3 over 2x is my second equation. Then both of them are y and y. With that, you already equate first equation into second equation. So you can say minus 2x plus 4 is equals to 3 over 2x. Then multiply everything with, just cross multiply. Then you get 2x times of minus 2x plus 4 equals to 3. So just turn up to minus 4x squared plus 8x We brought this to other side and form a quadratic equation. With that, you can get the answer. You can put it to the formula and you can obtain this answer. If you just work out, it's -4, 8, and -3. So that's turn up into 3/2 and 1/2. 3/2 and 1/2. We need the x coordinate. So initially, I just mark this information in this diagram. So this is 1/2 and this coordinate is 3/2. Now what you need to find is the exact region R. So how do you find the exact region R? Now you can see initially it formed a trapezium somewhere like this, according to this diagram. I can find this, this is a trapezium. Yeah. Then how to find the area of this trapezium? So initially I can find this height by substituting half into any of these equations. Then over here, this coordinate is 1/2 and this coordinate is 3/2. Right. Then if you substitute half into this one, you get this height. That is y equals to -2 times of half plus 4. That is turn up to 3. So this height becomes 3. And over here, this one you can substitute y equals to -2 times of 3/2 plus 4. That is turn up to 1. So this height is 1. Now you can find the area of this trapezium. We can say area, the area of the trapezium part of it, B, this trapezium area, you can say half A plus B. This height is, we already knew, that height is 3, other height is 1. 3 plus 1 into perpendicular height. Perpendicular height is the gap between these two. That's the perpendicular height. 3/2 minus 1/2. Minus 1/2. Right. So you get the answer. 3 plus 1 is 4 divided by 2 is 2. 2 into 1 is 2. Now that area is 2. Right. Then out of this one, if I remove this part of it, this area, you can get the required region R over here. How do you find this area? Simply we know that if you integrate the curve from, this is a curve. The curve is this bit from half to 3/2. You can get this answer for this question. Right. Then, yes. Right. Then there is a literal question over that, right? Okay. So part B, you need to find the area of this curve. This curve under this of this curve. This part is the integration from 1/2 to 3/2. But there is a technical question problem over here. 3/2x.
Yeah.
3/2x. For this question, what you need to do is you cannot apply the x to the power n formula. What you need to do is put in. I'll just get this answer only from integration. Not from integration means like you cannot use this formula for this formula. You can't use it for this question. X to the power n is x to the power n plus 1 over n plus 1. For this is not applicable for the question 1/x situation. Some k constant of this one. So anyway, 1/x integration is, you can use ln x. Later on we learn what is ln x. For the moment, I just put 3/2 ln x and do it. But this section we will be learning at later only to how to get this answer. For the moment, we will just do it and get this answer. But later on we learn how to do this. But for the moment, you cannot do this question today. So but anyway, just copy down this answer. Later on, we learn how to get this answer from ln function, because still we haven't learned the ln functions today.
Okay.
Answer become 1.65 today. 1.65. Therefore, the required region R is equal to 2 minus 1.65. That is answer is 0.35 would be the final answer for this. Right. That's a way of doing this question. But there's a technical problem with this question because you still for the moment you cannot, sorry, we cannot, you don't know how to do this integration for these functions, 1 over x functions. Yeah, that's the answer for that. Yeah, this is another interesting question. Yeah, over here. The figure shown above here is a curve of, this curve is y equals to minus 2x squared plus 4x, meet the line y equals to 3 over 2. So initially you need to find the coordinate of a and b. You have to solve these two equations as simultaneous equation. Minus 2x squared plus 4x, other one is y equals to 3 over 2. So if you equate these two, you get the answer minus 2x squared plus 4x is equals to 3 over 2. So you can bring this 3 over 2 to this and form a quadratic equation. Minus 2x squared plus 4x minus 3 over 2 is equals to 0. From here you can get the x coordinates. The x coordinate is, if you just do this, you will realize that you have to work out and get this answer. I'm just doing this. One answer is 3 over 2 and the other answer is 1 over 2. So this coordinate is simply it's 1 over 2 and here the coordinate is simply 3 over 2, right? Okay, find the region R. Then what you need to understand here is that if you integrate this curve from 1 over 2 to 3 over 2, you can understand that the area would be the area between the curve and the x-axis. So that is, you can get this whole area, this area. You get this area. This part of it only you get this answer. Okay, this whole thing. Right. That one you can get the answer by integrating 1 over 2 to 3 over 2 minus 2x squared plus 4x. If you do this integration, it's minus 2x, sorry, minus 2x to the power 3 over 3 plus 4x 2 over 2 from 1 over 2 to 3 over 2, right? With this, you can get the answer minus 2 over 3, 3 over 2 to the power 3 plus 4 divided by 2 is 2, 3 over 2 to the power 2 minus substitution of half per day. It is minus 2 over 3, 1 over 2 to the power 3 plus 4 divided by 2 is 2, 1 over 2 to the power 2. So that's the answer for that. So if you substitute these figures, that answer becomes 11 over 6 per 3. 11 over 6. Then to obtain the answer over here, we need to remove this area. From this area, if you remove this bit of it, if you remove this bit of this area, you can understand that you can obtain the area where is required for that. So you can say it's an area here is a rectangle. Yeah, in the rectangle, this length is half, 3 over 2 minus half is 1. This height is obviously we know that is turned up to 3 over 2. Right. Okay. From this area, you have to subtract the area over here, 1 into 3 over 2. So you get the answer minus, you get the answer as 1 over 3. That's a way of doing this question. Right, let's go to the next question. Yes. the next part of the question. Yes. Then they have given the diagram shows a part of the curve with equation y equals to 2x to the power 3 over 2. Right. So you can say, by just a little bit of expand, this is 3 over 2. Right. Minus 6x plus 10. The curve passes to the point 1, 6. So here, this is kind of important for us. This is 1 and this height is 6. 6 and the minimum turning point at B. So here, show that x coordinate of B is equals to 4. So simply we can understand that at a minimum point, minimum of whatever the turning point, dy by dx is equals to 0. That is the approach always we are talking about. 3 times of, if you just differentiate it, 3 over 2, x to the power 3 over 2 minus 1 is 1 over 2. Minus 6x differentiation is just 6. Right. That is, therefore you can turn up into this is 3x to the power half minus 6 is equals to 0. That means x to the power half is equals to 6 divided by 3 is 2. So x become 2 to the power reciprocal of it, 2, it's 4. So the x coordinate is 4. So simple situation, here the x coordinate is 4. Then we need this y coordinate as well, but because they didn't ask, but I think it might be useful for us to find the y coordinate over here. Right? Okay. That is how to find the y coordinate, but I'll just find out this y coordinate over here. So you can just put y equals to 2 times of 4 to the power 3 over 2 minus 6 times of 4 plus 10. So you get the answer. 2 times of 4 to the power 3 over 2 is 8. 16 minus 60, sorry, minus 24 plus 10. That answer is 2. This answer is 2. Okay. Right. Then obvious question, they want to find the region R, right? So what you can understand is, but initially you can see that this is a trapezium. This shape is a trapezium. This shape is a trapezium. So initially I try to find out that trapezium area. So you can say it's a shape like this. This height is, we already found this answer. This height is 6 and this height is 2 and 1 to 4. This length is 3. Therefore, you can say 2 plus 6 divided by 2 into 3. That area you can find it. 6, 8 divided by 2 is 4, it's 12. Yeah, 12, right. Then if you need to find this shaded region, you can understand that I need to remove this area. If I remove this area out of this orange color, this bit. If I remove this area, this bit of it, you can see that you can obtain the required region over here. Right? How to get that area? That is, it just you can say it's a curve somewhere like this. From where to where? This here, the coordinate is, we already knew, this coordinate is 1 and 4, 1 and 4, right? Then this area you can obtain by integrating from 1 to 4, the curve. Curve is 2x to the power 3 over 2 minus 6x plus 10. If you do this integration, that is 2x to the power 3 over 2 plus 1 is 5 over 2 over 5 over 2 minus 6x squared over 2 plus 10x from 1 to 4. Right? Okay. Then if you do this integration, you can say it's, I'll just do it here. That is 4 over 5, x to the power 5 over 2, minus 6 divided by 2 is 3, x to the power 2, it's not 3, it's 2, plus 10x from 4 to 1. So you can substitute 4 into this. 4 over 5, 4 to the power 5 over 2, minus 3 times of 4 to the power 2, plus 10 times of 4, this whole thing, minus substitution of 1 to the 4 over 5, 1 to the power 5 over 2, minus 3 to the power 1 is 2 plus 10 times of 1. So you can get the answer. You get the answer 49 over 5. 49 over 5. So with that, you can get the required region, trapezium minus the spread of it. So the required region R is equals to 12 minus 49 over 5. So with that, you get the answer 11 over 5 is the final answer for that. That's a way of doing this question today. Right, okay, let's go ahead with this. Just make it a bit smaller. And you can see the full question at once. Yeah, this is a part of it. Okay, this is the next part of the question.